Alright, this is my video for sprint number 9 of Game Engine Programming. Starting off with the shader and model manager assets, there's two new functions, one in each one, the load default shaders, and in the model manager we have the load default models, which if we're looking at these functions, it's just another load function that will be called in the load of the engine, and it's just default loading models that we're not expecting the users to load, so then they'll already be loaded in. And then on that same front, looking at the camera manager, we have a new camera UI camera and a get UI camera function to retrieve it. And then in the creation of the camera manager, we will set up the proper values for the UI camera, so that will already be generated for the user. And then we have a new asset manager, which is the image manager, which works similar to the other managers, except we have a create function instead of load, and we'll just take in a key of the name and then the texture and the rect for the image that we're going to create. And then we have a similar get function as well. And then inside, when we're loading it, we'll create a new image at that key using the texture and that rect. And inside the load all resources, there is an image manager function where the user can call create, naming their image of this texture, and then they can set the values at 0, 0, and then the width and height, since these are the full textures that are being used for the images. But if we actually go and look at the sprite, it's its own class that inherits from drawable, since that's the only functionality it uses from the GameObject class. In the constructor, we just take in the image and the rect that we'll use to create the graphics object sprite, which is stored here in this pointer. And then we have our functions to set scale by factor and pixel. We can also change the image used, and then our other functionalities here. Set origin, and then Sprite has its own draw, which it uses to draw itself, and then the user can call register draw and deregister draw. So if we're looking at that, register draw will just call in the drawable attorney, submit draw 2D registration, which is essentially the same draw registration process, except when we get back to the drawable manager, we will instead end up in this storage list 2D, which in the process elements will be processed after the storage list of the other drawable objects, guaranteeing that all 2D sprite drawables are being drawn last in the scene. But coming back to the sprite, we're looking in the CPP. We just have here in the constructor, we create the graphics object sprite using the model and the shader that come from those managers. This is something that the user wouldn't see, but we'll use the image and the rect they give us, and then we'll set default values for the scale, rotation, and transform. And then here we can change the image. The set origin uses bounds from -1 to 1 on the X and Y, which moves the origin from the center in different directions. So we'll take in those values and set the appropriate origin width and height, and change that in our matrix origin so that the origin and the rotation point will update. The scale by factor will just multiply our scale matrix by those values to increase it, and by the set scale by pixel, we will just take in the exact float width and height that the user wants, and then we will set those inside, changing our width and height to those exact values, and then set position, rotation, just modify the transform and rotation matrix, and in the rotation we only modify the Z since it's the only one that matters. In the draw of the sprite, we're just calling render to the UI camera. This is again something the user wouldn't have to do. It's in the sprite class. They would just have to call register draw or deregister draw. But if we come and look, we look in the tank object itself, it now contains 4 sprites: the UI shell, reticle, the body, and turret icon. which if we look in the constructor, we can call in here to say new sprite of this image, and then we set the position and the size of the sprites. And then you can see here we're setting the origins of these two different sprites since they are being set differently inside the scene, and then we're calling register draw on those so that they draw to the 2D camera. So if we run this, you'll see the UI of the enemy tank icons as well as the tank shell, and then the tank body and turret icon drawing here with the reticle in the center of the screen. So if we're moving around, see that, and then if I actually shoot an enemy, I can update the image of the sprites indicating that that enemy is now dead. And you can see that when I no longer have a shell to fire, the tank shell sprite stops drawing, and then when it returns it will draw again. And if we're looking down here at the UI turret icon, set origin at 0, 1, that is this sprite here, and we're setting the origin down at this bottom point here so that as I'm turning the tank, the sprite is rotating around that bottom point instead of the center of the sprite itself. And we can also check in here for the UI shell, that's the tank shell in the bottom left corner. If we set the pixel scale to 4040 so that it's a size of 4040, we'll see it change. See that sprite is now changed in scale. And if we just do a scale by factor of 2 so that we double the size, you'll see now the tank shell is twice as large, and since we're setting the origin at 1, -1, which is this top left, it's kind of shooting off down this way. But that is my sprint for the sprite class, and then my final piece of the puzzle for the engine is I'm now starting work on getting the documentation set up. It took a while to get Doxygen going, but this is almost ready to start being set up.